Okay, guys, so today we're going to talk about the distance formula. So if I'm looking for the distance between these two given points, I am essentially looking for the length of the line segment that does connect those 2 points. So let's say I draw a line segment here, so I connect these 2 points. Then I'm looking for the line segment length here. And I can take a look at that, and although we know how to tell distance if the line is horizontal or vertical, when a line is diagonal like this, it's kind of hard to do so. But we do have a formula for that, and if you remember the Pythagorean theorem tells us that in any right triangle, a squared plus b squared equals c squared. And A and B are the legs of a right triangle, and C is the hypotenuse, which is the diagonal part. So I can look at this and I can sort of create, and I'll use a different color here. In fact, I'll use a highlighter. I can look at this and I can create a right triangle. I can come down with this. It's kind of hard to see, so I'll do it like this. Let's see. Okay, and I can do the same thing across. And what we find here is we have a right triangle. And so in order to find A and B, I have to look at these side lengths. Before we start, let's identify these points. So this point would be -4, -6. And then this point up here would be 1, 6. So how would I find the length of this side? Surely I can count, or I can subtract the x values of the coordinates. And if I look here, I can make coordinates here of 1, -6. Okay, that's 1, -6 right here. So if I subtract the two x values, it will give me this side length. So in order to find A, let's say if we call this side A and this side B and this side C in a right triangle, in order to find A here, I start at -4, I go to 1. If I subtract them, 1 minus -4, that gives me A, and then I can square that. I can do the same thing for the y's here. How far away are these 2 points? Well, this one is at 6, this one is at -6, and if I subtract the two, 6 minus -6, I can get the distance here, and I would square that, and that would equal C. C squared, excuse me. So I know that if I subtract the two x's and square them, which is one side, subtract the two y's and square them, which is the second side, I would get the square of the hypotenuse here, or the hypotenuse squared. Well, how would I get the hypotenuse by itself? All I would have to do is just take the square root of both sides. And so C here, or the hypotenuse, is equal to the square root of, in this case, 1 minus -4 squared plus 6 minus -6 squared. Well, 1 minus -4, those were the two x's. 6 minus -6, those were the two y's, which actually gives us then our distance formula. And the reason that I did it this way is to show you that the distance formula is really just derived from the Pythagorean theorem. And so our distance formula, just like we have here, we subtracted two x's, x1 minus x2 squared, plus y1 minus y2 squared, and then you take the square root of the whole thing. If we were to do this problem, so we'll go back here, so the distance here is equal to, let's see, what is 1 minus -4? Well, that would just be the same thing as 1 plus 4, or 5, so 5 squared, plus 6 plus 6, that's 12, so 12 squared. Let's see, 5 squared is 25, plus 12 squared is 144, don't forget the square root. That equals the square root of 25 plus 144 is 169. And then I know that that equals the distance here is equal to 13 because the square root of 169 is 13. So we know that this right here is our distance formula. It's also important to note that it doesn't matter which order we put the x's and the y's, because if I switch this around, so if instead of doing 1 minus negative 4, and I'll show you here, if I did negative 4 minus 1, and I squared that, and then I added same thing, where I'm going to switch negative 6 minus 6 squared. Well, what would happen here? What's negative 4 minus 1? That's negative 5. Negative 6 minus 6, that's negative 12. Well, what happens when I square them? Well, negative 5 squared is 25. Negative 12 squared is 144. And it kind of takes me back to this step. So it doesn't matter the order that we put the x's and the y's as long as we follow this formula. Let's try another problem. Let's say here now the points are given to us, so we don't even have to figure out the points. So all we have to do is use the distance formula. Well, let's remember the distance formula. The distance is equal to x1 minus x2, that quantity is squared, plus y1 plus y2, and that quantity is squared, and you take the square root of the whole thing. So let's start plugging in some numbers. x1 and x2, that's 6 and 14. So the distance is equal to the square root of, let's see, 14 minus 6 squared plus, and here I'll switch around the order to make it easier for myself. I'll say 2 minus negative 13 squared. Again, it's important to note you can flip-flop the order of the y's or the order of the x's, as long as the x's stay together and the y's stay together. So the distance is equal, let's see, 14 minus 6 is going to be 8. So that's 8 squared plus 2 plus 13 here is 15. 15 squared. Let's see, 8 squared we know is 64. 15 squared is 225. 64 plus 225. That's going to be 289. And the square root of 289, if you don't know it off the top of your head, or you can use a calculator, the square root of 289 is a perfect square, and that would be 17. So the distance here is 17 units. Moving on to the next problem. Same idea. Again, I'm going to put the distance formula here. That should be minus, not plus. Okay, and then start plugging things in. Let's see. The distance is equal to the square root of negative 3 minus negative 10 squared plus 1 minus 0 squared. Okay, negative 3 minus negative 10 is like negative 3 plus 10. So we know that equals 7 squared, and then 1 minus 0 is 1 plus 1 squared. 7 squared is 49 plus 1 squared is 1. 49 plus 1 is 50. So the distance is equal to the square root of 50. Can I simplify the square root of 50? Well, let's see. It's not a perfect square, so I'm not going to get an integer or a whole number. Can I break it down? Does it have any perfect square factors? It does. I know that the square root of 50 is equal to the square root of 25 times the square root of 2. And I know that the square root of 25 is 5, so my distance here is 5 times the square root of 2. Last problem, okay, same idea. Okay, distance is equal to, and here I'll just do it right away, 4 minus negative 4 squared plus 8 minus 5 squared. Make it easier for myself to get positive numbers. So 4 minus negative 4, that's going to be 8. So 8 squared plus 8 minus 5 is 3. 3 squared. 8 squared is 64 plus 3 squared is 9. 64 plus 9 is 73. And now I think, well, 73 is not a perfect square. Does 73 have any perfect square factors? Let's see, can I divide it by 4? No, it's an odd number. Can I divide it by 9? 7 plus 3 is 10. The digits don't add up to 9, so it's not divisible by 9. The next one after that is 16. Well, it's also an odd number, so it's not going to be divisible by any even number. After that is 25. 25 times 3 is 75. That doesn't work. Next perfect square is 64. I'm sorry, next perfect square is 36. 36 times 2 is 72, so no. After that is 49. Nope. 64. So no perfect square factors, so here the distance is just the square root of 73.